Questions?
27.
And the second addition?
Yeah, this is long.
Oh, what does that say?
Find the local maximum and minimal value at set point of the function.
Oh,
Find maximum, minimum, that's
That
out
was
point. What's the function?
x squared plus y squared.
that's in parentheses.
Find
That's in
e
parentheses, that whole thing.
times e to the y squared minus x squared.
It started out innocently, you know. Okay. So what are we gonna do?
We're going to find the derivatives.
Okay.
So
Partial with respect to x is
2x, parentheses, e to y squared minus x squared, plus x squared plus y squared in parentheses, e to the y squared minus x squared, times negative 2.
times
Negative 2.
minus 2x.
Yes, negative 2x. I have it here.
Okay. And so we can actually factor out
The e to the y squared minus
2xe
x
to the
squared.
y squared minus x squared.
1
1
plus.
minus x squared minus y squared. Yeah.
Okay. And fy
And then fy is 2y, e to the y squared minus x squared, plus x squared plus y squared, 2y, e to the y squared minus x squared.
you can factor out a 2y e to the y squared minus x squared. That is 1 plus x squared plus y squared. Did they ask us to classify them too?
Yes.
So that means we have to find the other derivatives, right? fxx, fyy. Okay, what's the partial of this with respect to x?
Someone else gets to do it.
Oh.
I'm not gonna have this.
Okay, it's 2 e to the y squared minus x squared times negative 2x. Right?
I think I got 2x to the fourth minus 5x.
No.
Is that really wrong?
Well, I simplified it afterwards. I got 2e y squared minus x squared times 1 minus x squared plus minus y.
Will you start with the amount
That's right.
Yeah, right? He's doing it.
Let me do it.
Yeah.
Minus 2x.
Isn't that 2x squared? No, it's 2x. That might be my problem.
Weird.
Okay. Can we simplify this?
Yes.
Yes.
Good luck. This is why you
Okay,
have
so
the
this is
chalk
gonna
and
be-
we have the seats.
I took out the 2, so this is just minus x squared times 1 minus x squared minus y squared. And I took out the 2. Oh, so this is 2. Because I took out one of the 2's. And here I take out one of the 2's as well. So this is plus 2x squared.
Y squared.
Is that right?
Guess nobody get that right.
All right, I factored this off, so this guy's left in the first term. I took out this guy, so then I have minus 2x squared times this left here. Then I took out 2 times this, so I just have x times minus 2 So it's that. And so what does that simplify to? Yeah?
I didn't get the right answer, so.
So this is minus 2x squared, so this gives me 5 plus 2x to the fourth plus 2x squared y squared. So here we want fyy, which is this, right? So we're going to take the derivative with respect to y of this. This is 1 plus x squared plus 3y squared, 2y squared plus 2x squared y squared plus 2y to the fourth. fxy is are we going to use this one to take fxy? Just come again?
You mean fyx? No, xy.
Yes, but these functions are continuous.
Yeah.
So fxy is equal to
Same thing.
fyx. So here, if I had done with respect to y, the product rule, well, they're sort of the same thing. I need the product rule out of the way.
Same thing.
So, and I'll use this one anyway. So we want with respect to x.
Yep.
So we're going to differentiate this with respect to x, so that's going to be minus 4
xy.
xy plus this with respect to x, so that's just 2x times this.
4y squared.
4y squared.
4xy squared.
You take the weight.
2x.
4xy, 4xy.
4xy
e
squared.
to the block
I mean, 4xy e to the block.
minus 4.
Is it?
Oh, okay.
That's it. Okay, so now we set these equal to 0, right? So fx equals 0 is, what's fx? 2x e to the y squared minus x squared times 1 minus x squared minus y squared. And this is
2y e to the block times 1 plus x squared plus y squared.
so this equal to 0 and that equal to 0, which means what? this gives me either x equals 0 or
That thing equals 0.
x squared plus y squared is equal to 1, right? So now I'm going to plug both those situations into here. So if x equal to 0, I would have 2y e to the y squared times 1 plus y squared equals 0. This is never 0. This is also never 0, right? So I get y equals 0, which means I get the point 0, 0. And if x squared plus y squared equals 1, then I get 2y e. So this would mean that I can replace x squared with, well, it doesn't. X squared equals 1 minus y squared, right? And then I replace that here, so I put 1 minus y squared there, and then I would get 2y squared minus 1. And then here, I would actually get 2 equal to 0. This would mean that y equal to 0, which would mean that x is equal to 1, plus or minus 1. So that gives me 2 points here, 1 comma 0 or minus 1 comma 0. Were those the three? Are those all of them?
You know 31?
We're not done.
Oh, no.
We'll have to classify them.
Just half.
I got 0, 0, plus or minus 1, 0.
Yeah.
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 Insert, yeah.
Oh,
So
question.
if you said you never got that right, how did you get these three?
I thought I didn't get that right. Apparently I must have.
Question.
Yes.
Does that matter if you do this one first, fy equals 0 first, then get the y equals 0 and
Superpower.
y equals another one, and plugging into the fx?
No, you should get all the same answer.
Oh, okay.
Right. The goal is to solve for what you need in one, plug it into the other one, and that will give you everything. So it depends on, pick whichever one seems convenient. So now we have to classify. So what is 0, 0? We're going to look at the D for 0, 0.
It's 4.
It was 4.
Yeah.
Just
I
put
got-
in the small
Yeah.
0.
What is D, first of all? Tell me the formula.
fx,
Fx.
minus y squared.
So D of 0, 0 is equal to? If I plug in 0 here, what do I get? Just 2.
2.
Plug in 0 here, I also get 2. So that's 4.
4
You don't trust me.
And then if I plug in 0 here,
minus 0.
0. So it's actually 4.
I'm telling you, it's a superpower.
Okay, and then what's your sign of fxx? fxx is actually 2, right? Which is also
It's
greater than 0.
so it's a local local minimum.
Classify 1, 0. In this case, your D is equal to, what's 1, 0? What's D for 1, 0?
It came to minus 4e to the negative 1 times minus 4e to the negative 1 minus 0. So it's less than 0.
Just say less than 0 instead of both sides.
It was less than 0?
Yeah.
Yeah.
So 1, 0 is a saddle point.
Yeah.
Details left to the reader. You have to take the textbook approach right now. And I assume that this gave you less than 0 as well?
Yes.
Yep.
Now, how did you assume that?
Well, things were almost symmetric.
Sine always square and full power.
That one's a lot of algebra. Okay.
Not the only one.
All were.
Not all of them. Some of the ones in the start weren't. They were polynomials were nice.
9 wasn't any algebra, it was trig.
Okay. Other questions?
Yeah, number 27.
Second edition?
Second edition.
Oh, this one is like a little bit thick.
And what's that? What did that say?
Hang on, I'm pulling it up.
So we have this function. X to the power 4.
Do you have it? No, I don't have it. It's not in front of me.
What is it?
X to the power 4 plus y to the power 4 minus 4xy plus 2. And it's bounded by the region.
Wait, what was this?
Oh,
Yes.
it's a function. Function of x.
They just said f of x, y is this.
Yeah.
Yeah.
Okay. And then
And it's bounded by the region. For the x, it's 0 to 3. For the y, it's 0 to 2.
so you needed to find the absolute maximum, I suppose.
Yeah.
Yeah.
Right, so this is again one of the problems where you need 4 of them, right? So this is 0 to 3, 0 to 2. Anyway, so first we need to find the critical points, right? So we're going to need to find fx equals fy equals, this is 4x cubed minus 4y. And this is 4y cubed minus 4x. For critical points, you need to have 4x cubed minus 4y equals 0, and you need to have 4y cubed minus 4x equal to 0. So here you would need what? Y equals x cubed. So this means here you'd have 4x to the 9 minus 4x. So here you'd have 4x times x to the 8 minus
1.
1. And so the real solutions would be 0 and plus or minus 1. Right? But the y is x cubed, so you're just going to cube this. So you either get,
Why would it be plus or minus 1? That's an even function. X to the 8.
Yeah.
Wouldn't it just be 1?
No.
no, minus 1 to the 8 is a positive 1, and minus 1 to get to
Oh, okay.
Yeah. So critical, so the points are, if x is 0, your y is also 0. If x is 1, your y is the cube. And if your x is minus 1, the y is also the cube. So those are the critical points. Are all of them in our region? Well, 0, 0 is actually on the corner, so that's there. 1, 1.
Yep.
Yeah, 1, 1 would be in there, right? 1, 1 is here, but minus 1 is not, right? So we're not going to be considering this guy. Right? So now, we're going to test f of 0, 0. 2. Test f of 1, 1. This is 1 plus 1 minus 4. You also get 2. You what? That's 0. Okay, so now we also want to test the boundary. Test boundary. So let's look at D1. For D1, I know my y equals 0, where my x ranges between 0 and 3. So the function here is f of x0, which is going to be x to the 4th. And that's it, right? So a critical point is x equals 0. So I'm going to get f of 0, 0. endpoints is going to be when x is 0, I get f of 0 is 0, and when x is 3.
Yeah, Joel.
Yeah?
You don't?
Isn't f of 0, 0 equals 2?
Yes, I had to. So here I'm going to text f of 0, 0 again. I get 2, f of 3, 0. And I would get, wait. Oh, I'm missing the plus 2, that's why.
Yeah.
Okay. Now f of 3, 0, 3 to the 4th plus 2. Now if you test D2, on D2 we actually have x equals 3, and that's ranging from the y goes from 0 to 2. So our function would be 3 comma y. If I plug in 3 for x, what do I get?
Yeah, 81.
What?
3 in the function. 81
Y,
plus y 4.
minus 12y. 83.
So now to find the critical points, this means 4y cubed minus 12 equal to 0, right? And so I would have 4 times y cubed minus 3. And so y would be the cube root of 3.
Wait, it's cube root.
Is that, yes, the cube root of 3 is less than 2.
A cube root?
The cube root.
Yeah.
Right, which is actually less than 2. So then we are going to check 3 comma the cube root of 3. And what was that? That was actually 0?
I got about 70.
Really? So for the endpoints, I need y equals 0.
I thought that was approximately 70.
You got 70?
Approximately.
Approximately 70. Okay. And then now I test the endpoints when y is 0. This gives me 3, 0, which I feel like I tested before.
3.
When y equals 2, I get 3, 2. And that was what?
75.
And test D3. So here I have f of x2, which is, what's the function?
X to the 4 plus, oh, minus, sorry, minus 8x plus 18,
Plus what?
18.
18. Is that what you said?
Yep.
Okay. So, critical points, this means you have 4x cubed minus 8 equal to 0. Right, so that means x equals the cube root of 2.
Yep.
And so we test the critical point at cube root of 2 comma 2, and that was what?
Approximately 10.4.
Test the endpoints, that's when x equals 0 and when x equals 3. So 3, 2, I think I did before, that's 75. 0, comma 2, did we do that before?
18.
Last one, D4. For D4, we have x equals 0, where the y range is from 0 to 2. So we have f of 0 comma y would be y to the 4th plus 2. So critical points is y equals 0. So we test f of 0, 0, which we already found. 2 plus the endpoints. This means when y is 0, again I get f of 0, 0, and y is 2, so I get f of 0, 2. 4. Absolute max is absolute. What was the biggest guy? The 83?
Yep.
30. And the smallest was 2, was it?
No, it's 0.
Did we get a 0 something?
We got 0.
1, 1. Okay. Why do you guys do such annoying homework problems? Who
We
assigned
have
this?
this
Who
professor.
the hell assigned this stuff? Any other questions?
Oh, yeah. 33.
This is something like that?
No, it's more simplified.
31 to 35 are
31 to 35 or what?
completely different.
Oh yeah, the rules are
Yeah.
funky.
31 or 33 is kind of simple.
Very different, right?
Okay. Pick one. Which one do you want to do?
Pick all three.
Or the
33.
I feel like they'd be similar. They're in the same section.
31 and 33 is similar. Sorry, 35 is different.
So which one do you want
Which one?
33.
to? Okay.
And then 35.
What does 33 say?
Find the point on the cone z squared x squared plus y squared that are closer to the point 420.
Closest to 4 to 0.
Yep,
So we want
the point.
point on this guy that's closest to that. So it's actually an optimization problem, right? You want to minimize the distance function, basically. So the distance would look like what? The distance function would be the distance between x value in 4, y value in 2, and the z value in 0. Square. Right? So, of course, the trick is you can minimize the square of the distance.
The y term needs to be squared.
Right? It suffices to minimize d. What's the constraint? Right, so this is actually your objective equation here. Remember that term from Calc 1? So that's your objective equation, so you have a constraint equation, which is what? It's the actual equation of the cone. The constraint is your z squared must be equal to your x squared plus the y squared. And so you can substitute your constraint into the objective and find the minimum point.
Oh, are you going to do them with us?
No, I'm going to do that one because someone asked me.
Number 5? Which one?
The critical points.
The critical point.
Yeah.
Yeah, so
you
your
both version?
Yeah, find and classify the critical points of that function.
I finished half of that. We could have been done already.
It's okay, it's okay. 540 we go
Why
first.
couldn't we get like a nice function?
Yeah.
Does
So we
everyone know
can show
anything
you
about
we
that
knew what we
function?
were doing.
We could multiply it out,
in
man.
yeah.
You don't see it right
No, besides that.
I'm sorry, what was the
He's gonna say
question?
something I don't know if you'll feel good.
What was the question?
When either x or y is 0.
The function.
Yeah, well, no.
No.
Well, what I meant was,
I have no idea what he's saying.
Oh, you mean
Oh yeah, yeah, I know that. Yeah.
I solved this one just before.
yeah?
You literally just swapped out 100 for 1. But anyway, let's go through it again. So this was xy minus x squared y minus xy squared. So you find fx equals fy equals. On the other version, I think I made this the negative, so it was plus, plus, and minus.
Minus
But
one.
you can factor out the negative and everything else is sort of the same. Except I think your minimum point would now be a maximum point or something like that. So fx was, we have that y minus 2xy minus y squared. Fy was x minus x squared minus 2xy. Take this with respect to x, you have minus 2y. Take this with respect to y, you have minus 2x. Take x with respect to y.
So funny.
1 minus 2x minus 2y.
Okay, so now for critical points, you would need that y minus 2xy minus y squared equal to 0 and x minus x squared minus 2xy equal to 0. So for either one of these I can just factor. And here I have y equals 0 or y equals 1 minus 2x. Right? But now I'm not rejecting anything, right? Because I never said they have to be positive or anything. So I'm just keeping all the values. So now if I plug in y equals 0 into this, I would get x minus x squared equal to 0. So I have x equals 0 or x equals 1, right? So that means x can be 0 and y is 0, gives me 0, 0. Or x can be 1 while y is 0. So that gives me 1, 0. So that's 2 points from that one. And then I can plug in y is equal to 1 minus 2x into here. So I would have x minus x squared minus 2x times 1 minus 2x. So that would give me what? 3x squared
Minus x.
minus x equals 0. So I have x and I have 3x minus 1. So that gives you either x equal to 0 or x equals to 1/3. And then since y is equal to 1 minus 2x, when x equal to 0, y would be 1. And when x equals to the other value, 1/3, 1/3, y would be 1 minus 2/3, which is also 1/3. So I got 2 more values here, 0, 1, and a third, a third. So point 1 was 0, 0. For this guy, we just do the test, right? D is equal to, fxx, fyy, minus fxy. Which I asked you to reiterate that from in the question before that. So I just plug in 0, 0 in 0, 0, 1. So this gives you minus 1. Less than 0, so that's a saddle. If I look at critical point 2, which I can take to be 1, 0. And D is equal to I plug in, that would be 0 and
Minus 1.
that would be -1.
I think so.
Yeah, any of them would.
Yeah.
Yeah,
it
-1
does.
is correct. So that's 0, less than 0, so that's also a satellite.
Let's try and auto-stabilize or something.
Critical point 3, I can take 0, 1, and D was less than 0 as well, right? And that was a satellite again. For the fourth critical point, it was a third, in which case the D was what?
Local min.
Looking at
It should be max for you.
It was greater than 0 if you plugged in all the
Originate
numbers,
should be
and your
max.
fxx
It was
would have been what?
Yep.
Okay.
smaller.
It's like, just making sure.
If you plug in y equals a third, you get negative, right? So this is less than 0. So in this case, it's a local max. Right? In the other version, it's probably local.
So the critical point is all same thing?
Yeah, so there were 4 of them. There were 4 critical points. This.
Get 2 out of 4.
No, I mean in both versions.
Huh?
The critical point on both versions is something.
The points would be the same, except 1 was 0. Because I literally just took the surface and flipped it upside down by putting that negative. So the critical points aren't going to change, but what was highest is now going to be lowest. So
Can we review how you do rate of change?
Oh, that's pretty.
Oh, the
which one? Like from this?
Yeah.
number 4.
What if the D is, what if the D is 0?
Then this test gives you no information. You have to figure it out some other way. Right, so we looked at some examples like that before where we can just look at things like, oh, we know this is a square, so it's always positive, and you know every other point would be negative around it. You have to look at other things. Right, that test doesn't give you any information if D is 0.
You have to use your imagination. Magic.
4. Yeah, so here we had f of x, y, z was equal to 3x squared plus 4y cubed minus 2xy plus 4z. And I wanted the directional derivative at the point, so we want to add the point 1 minus 1, 2 in the direction 2, 0, 4. But first I asked you to find what u was. And how did we find u? Find the direction, right? This is the initial, and this is the final sum. So you just do 2 minus 1, 0 minus this, 4 minus 2. But you have to make sure it's a unit vector, so you divide by its magnitude. So that's just 2 root 6. So you can leave that as the answer. And so then duf would be equal to, this is still version 8. So earlier I asked you to find the define in terms of a dot product duf, so that was actually the gradient of f dot product with u, right? So now I know the gradient of f, we can find it, and I'm going to dot product the answer with 1, 1, 2. So now the gradient of f is, you take the partial with respect to x, you got 6x minus 2y, partial with respect to y, 12y minus 2x, partial with respect to z,
4.
is just 4. And I want to evaluate this at the base point, right? So I'm going to evaluate this when x, y, z is equal to 1 minus 1, 2. So if x I plug in 1 and minus 1, this would be 6 plus 2, right? That would be 8. This would be minus 12 minus 2. Right? Because y is negative 1.
Minus 14.
Then it's supposed to be 12y squared.
Yeah, 12y squared.
12y squared.
So 12 minus 2.
Right, so it's 12 minus 2, 10. And this was just a constant 4. Dot product that with 1, 1, 2 over radical 6. So that's just going to be 8 over radical 6 plus 10 over radical 6 plus another 8 over radical 6. Which is what?
26
That was part A. What's the maximum rate of change?
The square root of delta.
Magnitude of the gradient.
It's given by the magnitude of the directional derivative of the gradient at the point, right? So this is the gradient at 1 minus 1, 2. And then that we actually found here. So that's actually the magnitude of 8 squared plus 10 squared plus 4 squared. What was that? That's 1/8? Okay, I mean, you can simplify that if you want, but if you put that, it's 6 root 5.
Wait, we
Yeah.
have simplified? You don't have
I would have given it. C, what's the direction of maximum increase?
Would it be the gradient
maximum.
It is the direct, it's again this guy evaluated at the point. But now you're taking the direction, not the magnitude, right? But because I asked for the unit vector in the question, you divide by the magnitude of this.
This was on the question.
So this is just going to be 8, 10, 4 over radical of 180. Or you can do 8, 10, 4 over 6 radical of 5. Did anyone attempt the bonus?
Yes.
Getting
it is different than it.
Okay,
Yeah,
so we're in the
exactly.
first octant between z equals 16 minus x squared and the plane y equals 5. What does that actually look like?
Wait, what are you talking about?
Wait,
So we're doing bonus 1.
Oh, bonus one, okay.
That was the integrals, no?
Yeah. What does z equals 16 minus x squared look like?
Parabola expanding downwards from z equals 16.
Okay, so you have a parabola coming down like this, right? Starting at 16, and it's running along the y, right? Because there's no y. It's actually a cylinder. It's a parabolic cylinder, right? Now the plane y equals 5 is just a plane cutting through, right? It's parallel to the y's xz plane going through y equals 5. So you only want the part in the first octant, which is where everyone's non-negative. So you're really taking you're taking a solid that looks like this. Right? Now I want the volume of that thing, is what I was asking for. So how do we do that?
I'll go to the integral.
You think of this guy as your f of xy, right?
Yeah.
Which is a non-negative curve above this thing, right? So the volume is just going to be given by the integral of this function. The double integral of your f of x, which here is 16 minus x squared, the a over the region R, which is going to be the projection here. Now what is the projection there?
Y from 0 to
Right, if this is 16 minus x squared, it means it hits here when x is 4. And this is at y equals 5. So your y goes from 0 to 5, your x goes from 0 to 4. So I can have, there are constant limits, so it really doesn't matter what we do first. So 16 minus x squared dy dx, right? Which would actually give you, right, when you integrate that, you get y, you plug in 5 minus 0, so you just get 5 times the integral from 0 to 4 of 16 minus x squared dx, which is 5 times 16x minus x cubed over 3, 2, 4, and 0. So it's 5 times 16 times 4 minus,
4 cubed over 3.
come again?
4 cubed over 3.
Yeah, 4 cubed over 3.
Yeah, I feel like that.
You left it like that?
Yeah, that's pretty much arithmetic.
Well, that was the answer, right? The volume below a surface you can think of like that, right? So that's
I have a
what we
question.
can do. Yes.
This is 12.1 or 12.2?
This is 12.1
That's correct.
because it's a rectangular region. Any time that you know how to do that since 12.1. Let's look at something from 12.2, which was bonus problem 2. I know technically I haven't taught this yet, but let's see what you guys made of it.
Some very creative answers.
So what are you guys thinking? How would you think to do this?
Well,
And so let's do the first all this time.
So here's where we're going to start. Can you describe the region that I'm integrating over? So we know how to integrate over rectangles. We're actually not integrating over a rectangle here. Can you tell me what region we're integrating over? How do you determine the limits of your variables?
Where e to the x, or e to the x exists, because it can't be negative.
What?
Is it like an exponential curve?
It's a triangle.
Yeah.
I'm looking at the region of projection. I don't even care what that curve looks like. I just want to know what I'm integrating.
From 0 to 1 and then
That's an unbounded region.
What's from 0 to 1?
Y.
And the x is from
X,
0
right?
to 1.
Remember, you can match these guys up. These guys actually tell you the limits of the x and y. So by looking at this integral, I know two things. My y goes between x and the number 1, right? While my x goes between 0 and 1. Now, if I had to draw that region, what would that look like?
How do you know x goes between 0 and 1?
Because that's it.
It's the
dx,
math of x.
0 to 1.
Oh, I mean, okay, thank you.
Right, the limits on your integral, they define the interval that you're integrating, right, when you're at constants, right? Now, how would I draw that region in the xy plane?
You would do x is from 0 to 1 on the number line.
So let's actually draw these functions, right? What does y equal x look like?
A line.
Line going through the origin, positive slope.
Yeah.
What does y equal 1 look like?
Horizontal.
Horizontal line going like this. Okay. Now, if this intersects here, what would this point be?
1.
1, right? And that's the part I care about. Now, I know x go between 0 and 1, so I only care about this region here. But which one of these two regions do I care about now?
X equals y.
Can you shade the region that
The
I'm
bottom
integrating over?
The one closer to the y-axis, the top triangle.
The top triangle.
Yep.
How do you know it's
No.
the top triangle?
Because the lower boundary of
Right, the lower bound here, right? So when these guys describe y, this is the bottom, this is the top, right? So this is telling me the bottom function is x, the top function is 1, right? When your things are describing x, you're describing who's on the left goes down here, who's on the right goes up there, right? So this is actually my region. I'm integrating over a triangular region. Now, when I said reverse the order, what do I want to do?
Well,
it means I want to write my integral as dx dy, right? Because here it's dy dx, here it's dx dy. Now you can't just switch the numbers, right? When they were constants you could actually do that, but things actually change. Because we have the restriction that, and this is really 12.2 we're getting into, is that your constants are always on the outside. Right? When you're going inside, the functions start to come on, right? So you would have, and this increases with the number of integrals. So if here you have constants, here you have one variable functions, two variable functions, three variable functions going on towards the inside, right? Now we're going to talk about why we have to do this and see why it has to work out that way, but this is the basic idea. So here, my x went between constants. Now I want the y to go between constants, right? That's the idea. I want them to switch roles.
On the inverse function?
I don't need to find the inverse function. I just need to describe this same region in a different way. I need to describe it in such a way that my y goes between constants while the x goes between functions.
Okay.
Right? So how would I do that?
Y goes between 0 to 1.
Y is between 0 and 1. Yes,
And
right?
then-
Because here if I'm defining the shaded region, where does it extend from? When y is 0, all the way up to y equals 1.
And then x is
0
y to 1. Y is less than or equal to x. Is greater than or equal to x.
So now remember, when you're looking at x,
So you have
the
to-
upper guy is the guy on the right,
That would be y.
and the lower guy is the guy on the left. Right? So of this shaded region, what function is on the right? This,
X.
which is x equals y. So on the right, it's y. On the left, it's this function, which is the function 0. Which means if I wanted to write this as dx dy, it would be from 0 up to y, 0 up to 1. Now, can anyone tell me why I wanted to even switch the limits here? Why was that a good hint?
Then you have to integrate with respect to y, over y.
Because of what?
Because
y
I
would be a
integrate
constant.
e to the x over y with respect
Yeah, with
to
respect to y, what is the integral of e to the 1 over y? Can't do it, right? But now if I switch to x, I actually know the integral of e to the x over y with respect to x, right?
Yeah.
I actually know what that is.
1 over y.
So now if I switch to x, so if I tried to integrate with respect to y, I couldn't do it because I had like a 1 over y in the power, which e to the 1 over y we can't integrate. But now the variable is on top, the bottom is just a constant, that's fine. So the integral would be, if you have 0 to 1, 0 to y, e to the y over x, dx dy. This would be equal to 0 to 1. Now remember you do the inner integral first. Sorry, it's x over y. So what would the integral be? Y e to the x over y. Between 0 and y. Now if I plug in x equals y, what do I get? 1, right? I get y over y, which is just 1. So it's just y e to the 1. And if I plug in x equal to 0, I just get e to the 0, which is 1. Right? So it's this. So this is just actually e minus 1 times integral from 0 to 1 of the function y. Right? I can just factor the y out. E minus 1 is a constant, which means I can pull that out. And now I just integrate that. So it's e minus 1. And this is y squared over 2 between 0 and 1, which is just a half. So that was the answer to that one. So
There's nothing special about this that we
How
didn't
long
already
would that
know.
take to do two problems?
From
It's how long we have
12.1,
to do
right?
quiz.
Other
It's
than
just a
probably-
slight extension part on what we know from 12.1. So 12.1 we learned to do over rectangles, right? In 12.2 we're going to learn to do over general regions. So I can give you a triangle, I can tell you a parabolic region, I can tell you a circular region. And circular regions we're going to find another way to do it. But one of the main differences is something like this, right? Where you know that constants always have to be on the outside. The way you set it up is going to matter a lot more from now on, right? Because it's not like you can just throw them wherever, right? You have to set it up so constants are on the outside, functions are on the inside, right? And the functions increase in dimension, right? So constants, curves, surfaces, volumes, hypervolumes, right? As long as you start moving in, your dimensions and variables that you can have on your limits will increase. Right? So that's sort of a preview to 12.2. 12.1, we basically finished it. I mean, the only thing I wanted to explain was why you can just, if you have a function of x and a function of y, why can you say that's just, why can you multiply the integrals like this? Right, why is this equal to that? Right, and I was talking about that last time.
Because in each one, either one
So anyone can tell me why that works?
Because you said so.
Because they're not.
They're in a different region.
Because,
Yeah.
like, if I'm doing here A, B, C, D. So this would be A to B. Now remember you do the inside first, right? C to D. Here you have fx, g of y.
Oh, because
Why?
f of x is then a,
Now your f of x is a constant
Constant.
because you're integrating with respect to dy. So what can you do? You can like factor that out. But now what? This is a definite integral, which means after you evaluate, it would be a constant itself, which means that thing you could factor out. Right? And you can literally just take the product of integrals once you can separate the variables. But again, this only works nicely in the sense that you don't have to think about it in 12.1. Because in 12.2, if I had functions here, right, then I could have x's here. And then this is not a constant anymore, because there'd be x's on the limit that I'm going to plug in. So this would be a function of x, which means I can't just be factoring things out. Right? But as long as your limits are constants, this can work and you don't really have to worry about it. Right? Once you start throwing curves on your limits, things can change quite a bit, and we'll see how much they change when we do 12.2. But for now, we'll just end with that. So the test is on Tuesday. Look over the review problems. We'll answer some questions on that on Monday, and then continue with chapter 12. So this means your d is actually equal to x minus 4 squared plus y minus 2 squared plus x squared plus y squared. Now d sub x would be 2x minus 4 plus 2x. D sub y would be 2y minus 2 plus 2y. Dxx would be just 4. Dyy would be 4. Dxy would be
0.
Zero. Now we have to find the critical points. And our critical points are going to be where 2x minus 4 plus 2x equal to 0, and 3y minus 2 plus 2y equal to 0. So what is x?
You got 2.
Hmm?
x equals 2.
No.
And your y?
1.
So 2 comma 1 is the only critical point. And so now d for 2 comma 1 is, it's just 4 times 4, that's just 16, right? It's greater than 0. And since dxx is greater than 0, this means 2 comma 1 is a minimum. Which means when my x and y is 2 and 1, that gives me the minimum distance. This means that z squared is equal to 2 squared plus 1 squared, which is 5. And z is equal to plus or minus radical 5. So the closest points are 2, 1 radical 5. 2, 1 minus radical 5. So it was just an optimization problem. So you follow the same steps from optimization. You find your objective function, you find a constraint function, you plug the constraint into the objective, and you find the minimum. Because we needed to find the minimum. What is 35?
Yeah.
You have find three positive numbers whose sum is 100 and whose product is the maximum.
So let the numbers be x, y, z. So we know that this x plus y plus z is equal to 100. This is our constraint. And p is equal to x, y, z. This is the objective. This means that p is equal to x, y. I can solve for z from the constraint, plug it into the objective. So this is equal to 100 xy minus x squared y minus xy squared. Find partial with respect to x, that's 100y minus 2xy minus y squared. Partial with respect to y. 100x minus x squared minus 2xy. Partial with respect to x again, minus 2y. Partial with respect to y again,
Minus 2x.
minus 2x. Partial with respect to xy. So you take this and take the partial with respect to y. I would have 100 minus 2x. So for critical points, we have what? We have y times 100 minus 2x minus y equal to 0. And we have x times 100 minus x minus 2y equal to 0. So here I can have y equals 0 or y equals 100 minus 2x. Here if y equals 0, I would end up with x times 100 minus x equal to 0, which means x equals 0, or x equals 100. Immediately reject 0 because I want positive numbers.
You can reject both of them because y also has to be positive.
Oh, I didn't figure out what y was.
Well, you can-
Oh, here, yeah. We didn't even have to do y equals 0 because we want positive numbers. 0 is not positive, so I didn't have to check that. So now just plug in y equals 100 minus 2x. So I have x times 100 0, or x would be equal to what for the last one? I'll go first.
Yeah, it's 100 over 3.
It's 100 over 3. Over 3?
Yeah.
Yeah. Yes, okay. So 100 over 3, which means your y is equal to 100 minus 200 over 3, which is 100 over 3, which means that your z is equal to also 100 over 3. So those are the three numbers. You guys remember how to find tangent planes of level surfaces?
Yes.
No, why not?
It's a gradient of f times the unit vector, the direction vector.
With tangent plane.
The tangent plane.
I wrote the
right.
direction.
Direction. I never said direction. So what if I said something like, find the equation of the tangent plane to what if I ask that question? How would you do it?
Well, you could set it equal to 0 first, and then you find what the z value is, and then x on y equals that to give you the point.
So you said, what did you want? Set it equal to 0?
Yeah.
And then what?
And then to find the point, you could do
Take the partials.
Right, you can look at this guy as one big f of x, y, z. And so you can find the gradient of that guy, which is?
x partial.
2x what?
xy
2xy
plus 2y squared minus 3. And then for the y, it would be x squared minus 4x y. That's it. And for z, it's negative 2.
Negative 2, yeah.
So that vector. Now, how do I get to the normal? You evaluate it at the point, right? Which is x, y, z equals
1, -1,
it would be 1 minus 1. What would be the z value?
0.
Should we just plug it in the equation?
Yeah, you plug in your x and y values here and you got 0. Is 0 the answer?
No.
Okay, so why didn't you start with 0?
So
1,
it's negative 1
-1, 1, 2,
plus 2.
3.
1.
Oh, no.
2? Did you get 2? Oh wait, no, hold on. There's more. There's more. 2, 4, 5. over 5? I don't know. I got 2 over 5.
2 over 7.
2 over 5.
What is it? Huh? Like you don't know how to solve for this? You plug in 1 and minus 1?
It's, oh, sorry, it's 5 over 2.
5 over 2.
No one wants to do it.
No, it's 5 over 2. Okay,
It's 5
keep
over
going.
2.
There you go.
0.
Alright.
0, 0.
Now it's what?
3.
That's cheating.
No, it was 5 over 2.
It's true.
Now we have to figure it out again.
Oh, you're tall.
Now what is it?
0, 0.
0?
Right?
It's 2.
Yeah, minus
It's 2?
3 plus
True.
4.
It's true.
1.
That's
you keep
0.
erasing the
This
numbers,
is
we're
minus
never gonna
3
get it.
Plus 4.
It's -1.
That's 1. Then you
Negative
move
1.
this minus 3 over here. You get 4. Then you
4
divide by
over
2.
2.
That's 2.
Anyway, so you evaluate this when y is 0, y is 0 kills these, so that's just minus 3. This is just 1. This would be minus 2, right? So that's actually your normal vector. You take the gradient and you evaluate it at the point. So now the tangent plane is what?
-3 x minus
Plus.
plus
Plus 1 times y minus 0
minus 2
minus 2.
Okay, can you go through that the way you got the point again?
Oh, so I told you at the point where x is 1 and y is 0.
Okay.
So because I know it's on this surface, I plug in 1 and 0 for x and y. And then solve for the z. And I got 2. Alright? And I evaluate this at that point, and I get that. Now when you evaluate the gradient at the point, you get the normal vector. And so that gives me the coefficients here. And then I just plug in the point 1, 0, 2 here. 1, 0, 2.
Okay.
And so that would be the time.
The most difficult part of that was just adding.
I told you, it's like when you asked us the other day what 3 minus 4 is, and you sat there and going, huh?
Alright, put your stuff away.
It's time.
Yes, time for the test. You guys had all week with the review problems.
What?
So
Very funny.
one day there's really going to be a test, and I'm going to say it, and no one's going to believe me.
You're right.
Revenge is going to be so sweet.
Like the boy who cried wolf.
Yeah, the wolf eventually comes, right?